So where we left off, we were able to get the equation for this parabola with the focus where we wanted it to be. Right here. Okay, so now we actually want to get a picture of this. Okay, so this is kind of tough to do because we're used to plugging in x's and getting y's, but all of these y's are squared. So here's how we're going to do it. So we know focus is at -2, 0. So we've identified that guy. Okay, you can put a little F there to let you know. Means our center's at the origin, so we have that directrix over here at x equals +2. We know it opens this way. We just need some more exact points for it. So you're going to just pretend there's a line going perpendicular right through this focus here. The equation of that guy is x equals -2. So we're arbitrarily picking an x value, but it is our directrix value. So if you take that -2 and you throw it in right here, you get y squared equals 16, which means plus and minus 4. So when you plug in a -2, it spits out a 4. When you plug in a -2, it also spits out a -4. So we strategically picked that x value for a reason, in that it now gives us enough points to draw our parabola. So in Algebra 2, I always ask for 5 points. In this case, we're going to use these guys here. Okay, so 3 points. So your center, and then these guys coming through the focus right here. Okay, and that's what it would look like. Now, there's a special name for this guy right here. Okay, if we take that line segment there, this was 4, this was 4, for a total of 8. This is 2, and this is 2, for a total of 4. So the distance focus to directrix is the same as focus up to the point. Okay, focus to directrix is the same as focus down to the point right there. That line right here has a special name, and I'm glad you guys are doing this at home so we don't have to all giggle in immaturity. I'm not sure why they called it this, but it's the latus rectum. So get all your giggling out of the way now. That's what it looks like. All right. We looked at them that open left to right. So now we're just going to briefly talk about what you guys are used to is those guys opening up or down. Now, if I give you one that opens up or down, you've had enough experience with it that you guys can graph. Okay? But I also want to show you how to do it this new way with the focus and the directrix. So this guy right here, you know, is your vertex form. And eventually that's kind of going to be what we're going to look like. So if I ask you to discuss this guy right here, x squared equals -12y, okay? You get two choices. You can do it how you guys have done this before. So if I take this guy here and you divide by -12, you get -1/12 x squared, okay? It opens down because it's a negative, and it's going to be super, super wide because of the 1/12. Okay, if it was a 12x squared, it'd be super skinny. Now the problem with that is you'd have to pull up your calculator here and get some x values. They're going to spit out good quality y values. Okay, so you don't want to be trying to graph fractions and ugly stuff like that. Okay. So if you go to your calculator and you say -x squared divided by 12, and you pull up a table, okay, you don't want to be trying to graph all these ugly points. 6, -3, that's a good point. So then you should have one back here as well, -6, 3. Okay, so you can do it that way. That's fine with me. If we want to do it this other way, we should also have a formula that says x squared equals 4 times a times y. if we have a y squared equals 4 times a times x. It's just a matter of which way these guys open. So now I want to try and get this form here to match up with something like that. So how could you take a negative 12 and break it down where you have a 4 and an a? Something exactly like this. So this will be your focus. Okay, we know it's negative 3. Now there's two places with negative 3, but we know since it's an x squared, we talked about it over here, it's got to be down there. So your focus is going to be 0 and negative 3. So if you were trying to graph that doing this new method, you could put your focus right here. Think about the lattice rectum point coming across here. So what's the equation of that line? Y equals negative 3. So if you go plug in negative 3 right in here, so you get x squared equals 36 plus or minus 6. So when you have a 6, you can get a negative 3. When you have a negative 6, you can get a negative 3. And there's your parabola. That was the exact same thing as us going to our table and finding those points. So it's good practice to try and do those guys both ways. So that's going to be it for part 1 there. Part 2, or day 2 of this, I guess, we'll look at how we do these parabolas when the center is not at the origin.